Welcome back to your final exam review for Algebra 1 Semester 1. We're working with problem 53 or whatever number it is this year, and the idea is they gave us some graph, and this looks like a linear absolute value graph. We see that V shape that's going on right here, and a few things to notice. First, there are some arrows at the end. The arrows, of course, mean that our function goes on forever and ever in both of these directions, keeps going down and down and down. Second, we should notice that our function stops at the x-axis here. Right? So if you think about a couple points on here, I don't know, maybe we'll pick this point. This is 1, 2, 3. This is the point 4, negative 2. This is over here, the point negative 4, negative 2. This point over here is 5, 6, 7, 8, negative 8, negative 4. This one is going to be positive 8, positive 4. See if you can see some patterns. I'm sorry, positive 8, negative 4. For example, our x values on here, we have some negative x's and some positive x's. But for our y's, we have negative y, negative y, negative y, negative y. And it's important to think about that pattern because we need to go through and analyze the answers down below, and that pattern is going to help us. So let's take a look. First, our function increases over the interval 0 to 6. Now, this interval notation is something that we haven't talked about yet, and if I remember correctly, it's something that's not on your final. However, it's important to know what it means eventually, so let's chat about it now. 0 to 6 means we start at an x of 0, and an x of 0 is actually, I think, the vertex 0, 0. That's when x is 0. And then it means it ends at an x of 6. 1, 2, 3, 4, 5, 6. Here's an x of 6. So if I highlight the graph just on that interval, and we look at that green line, would we say that that green line is increasing? Well, I hope not. The green part is going down. It's going like a downward slope. So our function's actually decreasing on that interval, and it's not f. What I think you will see this written as on your test is they'll say the function increases over the interval x such that 0 is less than or equal to x, which is less than or equal to 6. And that's just a fancy way to tell you what x's you're looking at, and our function is decreasing on that interval. G says the rate of change over the interval negative 8 to negative 2 is 1/2. Well, rate of change is just a fancy way to say slope. So let's go ahead and look at the slope from an x of negative 8 to an x of negative 2. And again, that would be written like this. So negative 8 is right here, negative 2 is right here, and it says, is that slope 1/2? Well, I don't know, let's see. If we wanted to find the slope, we'd have to go up 1, 2, 3, so I went up 3, and then over 1, 2, 3, 4, 5, 6. It looks like it's up 3 over 6. So I'm getting for g that my slope is up 3 over 6. Is that 1/2? Well, I think actually if you reduce our fraction, if you divide by 3, you do actually get 1/2. So yeah, our rate of change from negative 8 to negative 2, this little piece right here, is definitely 1/2. Alright, letter H. Is our domain all real numbers? Now remember, our domain is just a list of what all the x's are going to be. So what is x in here? Well, remember I highlighted x in that green highlighter. We have x's that are negative numbers, we have x that's 0, we have x that are positive numbers. I think our x's can be any number on here. Another way you can check that is you look at the x-axis and say, if I draw a line through, let's start at 8, through an x of 8, does it eventually cross over the graph? And it does. An x of 3 touches the graph, negative 3 touches, negative 5, negative 8. Really, any x value you pick is going to match up to the graph. And so we say our domain is all real numbers. X can be anything. So x such that x is all real numbers. Okay? So then, knowing I says, is the domain the x's on our graph are only numbers that are smaller than 0? Well, these are x's that are smaller than 0 for sure. But then the x's on this side, notice 4 and 8, those are bigger than 0. And our domain is saying we only have x's smaller than 0. Well, that's not true. We have x's bigger, so we can't use I. Then we look at the range. The range is all real numbers. Well, all real numbers would mean you can have any y value on there. And we have negative y values. These are also negative y values. Are there any positive y values on here? I mean, let's just pick a point. Let's pick a point with a positive y value. pick any x, I'll even do a negative. Let's do like negative 2 comma, let's pick a positive y, like 3. Negative 2 comma 1, 2, 3 would be up here. That's above the x-axis. The positive y-axis is above, and our graph never goes above the x-axis. So our range is not all real numbers. We only actually are using negative numbers for y. So I is out. I'm sorry, that's j, isn't it? J is out, and then we're on to k. K says the range is y is less than or equal to 0. And again, on your test, you'll see it written like this. Y such that y is less than or equal to 0. And is that true? Well, on here, our y's are only below the x-axis. It's only the negative part of the y. So yeah, that is true. Our range is y's are only numbers smaller than 0 or equal to. Last but not least, we have to choose between L and M. They are giving us the equation for this function. Absolute value, we see that V-shaped graph. Both of these have nothing adding, so we know that they both start at 0, 0, so it really comes down to the slope. Do we go down 2 over 1 or up 1 over 2? So if I take a peek, down 2 over 1 would mean to start here and go down 1, 2 over 1 in each direction. And I think that clearly is not the same as the graph we have there. The other one says it's a slope of positive 1/2. Positive absolute value would go up 1 over 2, up 1 over 2, and you'll notice that that also doesn't match the graph. So therefore, those ones are both out, and our three answers are G, H, and K.